This is the first of two lessons on synthetic division involving polynomials. We're going to look at in this lesson how you divide polynomials using synthetic division and in what cases that's useful. When we have a problem that will work with synthetic division, it's much faster and easier to do that than it is to do polynomial long division. But in order to do that, we have to make sure that our divisor, the polynomial that we're dividing by, takes a certain form. And in the case of synthetic division, that form has to be x minus r, where x is a variable x or some other variable with a lead coefficient of 1, and r is a constant, a number that has just any value as long as it is a constant number. And so if we look at the example that I've put up right up above, you'll see that this example does fit that. Right here our divisor is x minus 4, so you can see that x has a coefficient of 1, and r would have a value of 4 since we have x minus 4. Now if it had said x plus 4, then our r value of course could have been negative. It would have been negative 4 if it had said x plus 4. I like to just think about it as the opposite sign each time that we're going to use. And once it fits that form, then here's what you have to do to set up a synthetic division problem. We're going to put whatever that number is for r, whatever the value for r is. In this case it's 4. I'm going to write it right here. I'm going to put a little mark like this. And then what I'm going to do is I'm going to list the coefficients of each one of the variables in the original problem. Here, 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 and here, along with their signs. So in this case I'm going to write down 2, negative 13, positive 26, and negative 24. And I'm going to leave a little space right here, and I'm going to draw a line. And I'm going to just bring down that first coefficient 2. And now what I'm going to do is I'm going to multiply the 4, this is times, I'm going to multiply the 4 by the 2, and I'm going to put the result right here. In this case, the result is 8. And I'm going to combine the negative 13 and the 8, which gives me negative 5, and write it right here. And then I'm going to do that all again. This time I'm going to multiply 4 times negative 5, and I'm going to get negative 20. And I'm going to combine 26 and negative 20, getting positive 6. And finally I'm going to do 4 times 6, that gives me 24. Notice that 24 and negative 24, when I put them together, equals 0. That would have been our remainder, but we don't have one. And then to write out the final problem, I count backwards basically. This is the constant. This is my value for x. This is my value for x squared. 0 would be the remainder. So when I write this out, I'm going to write 2x squared minus 5x plus 6. And that is my answer for that division of 2x cubed minus 13x squared plus 26x minus 24 divided by x minus 4 using synthetic division. A much shorter, much quicker way of doing things than doing it with polynomial long division. Let's look at one more. Again, when I look at this problem, first thing I have to look at to decide if I can use synthetic division is the divisor. Does it take the form of x minus r? And this one does. Again, the lead coefficient, the coefficient in front of x, is 1. And then r in this case is not positive 2. R itself would have to equal negative 2. I have to be careful with that because it has to be the opposite sign in order for the form to take on x minus r. So x minus minus 2 is x plus 2. So again, we're going to write out whatever that number is out here. We've got to be careful again. This has to be negative 2. That's our r. And then I'm going to write all the coefficients. I'm going to write 4, and then I discover that there is no x cubed. I can't just skip it though. Since there is no x cubed, I have to write a 0 for x cubed, and then 2 for x squared, and then minus 4 for x, and finally 12 for the constant. That's really important that I've don't skip that 0. A lot of people will miss that. Once you start the descending order of exponents, you don't ever want to skip one. If there's any exponent missing, that means its coefficient is 0. You need to include it as part of your synthetic division. So again, I'm going to bring the 4 down, draw my line, and now I'm just going to begin to multiply. 4 times negative 2 is negative 8. 0 and negative 8 is negative 8. Negative 8 times negative 2 is now positive 16. Plus 2 is 18. Negative 2 times 18 is negative 36. Negative 36 and negative 4 is negative 40. And negative 40 times 2 is negative 80. Positive 80, excuse me. And we add those two together, and that's 92. Remember here that 92 is our remainder this time. That means that negative 40 is our constant. That's our coefficient for x, x squared, and x to the third. So when we write out this answer, we write 4 x to the third minus 8x squared plus 18x minus 40, and our remainder of 92 is plus 92 written over our original divisor, which in this case is x plus 2. And that's our solution using synthetic division. Again, a much shorter way to get the answer than doing that same problem with long division would have been. So synthetic division, as long as you have the divisor in the form of x minus r, is a very good way to do division with polynomials. In the second lesson on this, we will look at how you can actually convert a fairly simple version of the divisor that maybe doesn't quite fit that form into one that does fit the form, so that you can still use synthetic division. Thanks for watching. If you want to find lesson 2 on this, you can go to mymatheducation.com or Mymatheducation on YouTube. And also we have other topics of interest in Algebra 1, just algebra in general, on the same site and on the same YouTube channel. Thanks for watching this one. Hope you enjoyed it. If you did, maybe you could subscribe to my YouTube channel, and you can find more videos. Thanks again.